Okay, now we have a problem here, variation. This problem falls in direct variation. Now problem 1, we have question 1. See, given that d varies directly as t and that d is equivalent to 86 when t is equal to 2, find the following. A, we got the constant of variation. B, we have the value of d when t is exactly equal to 3. Now, how do I go solving this problem? We have two ways of solving this problem. You could probably use the formula by saying y is equal to kx. This formula 1, f1. You could probably say y1 or x1 is equivalent to y2 or x2. This is formula 2. If you use any of these formula, you will give the exact value that you will get for the first formula. Okay, so let's see how we can use the formula. We want to find a constant of variation because in our problem we're asked to find a constant of variation. So how do I go find a constant of variation? We want to use the first formula, y is equal to kx. Now we know exactly that we're not asked for y, but the formula shows that we use y is equal to kx. So whatever value you are asked for here or that you are given in the problem will be taking the value of y. So the answer to find d. So we could probably say d varies directly as t. How do I write this? Because in our problem I say d varies directly as t. So the value of this formula is y varies directly as x. In case a constant of variation, so here we could probably say d varies directly as kx. So what is the value of d? In the problem I said d is equal to 86. So we could say 86 is equal to k. And what is x? In the problem, in the formula here, x is representing t for our problem. So what is the value of t? We know that t is equal to 2 exactly. But in the problem it said d varies directly as t. And d is equal to 86 when t is equal to 2. So we come here, write our y, write 2. So we got 86 will be equal to 2k. Because if you multiply k by 2 or 2 by k, you will get 2k. So we want to find a constant of variation. We divide this by 2. We come here, we divide this by 2. We cancel because we don't want to, we want k. So k now stands alone, and we got 86 divided by 2. What is 86 divided by 2? What value do we got here? We should get probably something equal to 43. They haven't shown, but let's try to do this. We got 86 divided by 2. We know 2 can go into 8. How many times? 4 times. 4 times 2 will give you 8. We are left with 0. Bring 6. So 2 into 6, we got 3. So we say is equal to 43. So we got 43. So now we could probably say the constant of variation solution. We could say the constant of variation k is exactly equals 43. Okay, so the constant of variation here is 43. K is equal to 43. And we're also asked to find the value of d when t is equal to 3. So if we are asked to find the value of d, that means d is unknown. So we come here and say d varies directly as kt. We still got it. And we know that we got k, we got a value of k now. K is 43. So what is D? They asked us to find D, so D is unknown. So D will be equal to, what is the value of K? We got 43. 43, we got what here? We got 2. So D is exactly equal to 3 in our problem B. So we got 3 here. So now D will be equal to what? We got 43 multiplied by 3. We got 3 times 3, it will give us 9. We got 3 times 4, it gives us 12. So our answer D will be equal to 129. Okay, so this is how we solve direct derivation. You ought to use two formulas. We got two formulas exactly that we can use and get the same answer. So we got y is equal to kx using a constant of variation formula. We also use y1 or x1 is equal to y2 or x2. So you see that we got our solution, the constant of variation k is exactly equal to 43. Now we come to problem 2. Problem B, the value of D when t is equal to 3. Now we observe that t is not equal to 2 now, but t is equal to 3 when we were asked to find the value of D. Okay, so thanks for watching this movie. Hope you like it.